In this video, we are going to discuss about a simple but very important problems. So this diagonals of a rhombus bisect at a right angle. Now let's see the problems. So show that the diagonal of rhombus bisects one another at right angle. So first we see the diagram of these problems. So this is a ABCD rhombus. So first we should know about the rhombus. So this rhombus means this is a square. Means it's all sides are equal, but it's these four angles not equal with the right angle. Means these four angles means the more than 90 degree or is the less than 90 degree, and also its diagonal are not equal. Means this AC diagonal not equals with this BD diagonal. But we have to prove that this point O on this point, in this point, so this O point is the bisect of this AC line and this bisect of this BD line on this all angles, this AOD angle, DOC angle, and this COB angle, and this AOB angles are 90 degree. Okay. Now we see here this ABCDBA rhombus and this AC and BD cut at point O, and it is required to be proved that this diagonals AC, this diagonals AC and this diagonal BD is this intersecting point, means this O. This O point is the bisect is the one another at right angles in the point O. Now see the proof. Now you see here this is a diagram, and in this diagram this ABC is the triangle and another triangle is the ADC, and we have to prove these two triangles are equal in all respect. So how we will prove that? So this AB equals to AD, means this line, this AB line equals to this AD line. Okay. And this BC line is equals to CD line. And this AC line is the common for this both triangle. So we can say these two triangles, this corresponding three sides are equal. So these two triangles ABC equals to triangle ADC in all respect, and this corresponding three sides and this corresponding three angles are equal in this both triangle. So we can say easily this is the BCA angle. So this angle is equals to this DCA angle, means this angle. Now let's see the diagram here. So this is a ABCD rhombus, and this is a two diagonal is here. This is a AC diagonal and is the BC diagonal. But we have to this is the required to prove that this BOC triangle is equal with this DOC triangle. So how will prove that these two triangles are equal? So in this earlier we have proved this angle, this DCB angle is equals to OCB angle. This OCB angle is equals to OCD angle or DCO angle. Now this BC sides equals to CD side, and this OC is the common for this both triangle. So we can say these two triangles, this BOC triangle and this DOC triangle is equal in all respect. And it is come from theorem 4. So if you want to watch, if you want to know more about these things, so please watch my video about this theorem 4. Now this we can say, so it is equal in all respect means its three sides and three angles are equal. So we can say this BO equals to OD, and this two angle, this COD angle is equals to BOC angle. Now this is a straight line, and this straight line angle is the 2 phi, and these two angles are equal. So this each angle should be pi. This is the pi and this is the pi. So we can say this COB or this BOC and this angle COD are right angle, and this point O is the bisector of this BD line. Now you see here, this require one another angle. This angle is required to prove that this AOD angle is required to prove that this DOC angle is the equal. So we can easily say these two angles are right angle, and this point, this O point is the middle point of this AC line. So how we'll prove that? So here this is the ADB. This is the ADB means this is this triangle, and another triangle is the DCB triangle means this triangle, and it is required to prove that these two triangles are equal in all respect. Now you see, so here this AD equals to DC, okay, and this AB equals to BC, and this BD is the common line. So this is the common line for this both triangle. So we can say these two triangles, means this ADB triangle and this DCB triangle are equal in all respect, means all three sides and three angles are corresponding angles are equal for this both triangle. So we can say this ADB means this angle is equals to this angle CDB angle. Now this triangle AOD, this triangle and this triangle DOC, this triangle, it is required to prove this triangle should be equal in all respect. So here this AD equals to DC, and this two angle are equal means this ADO angle equals to ODC angle, this one, and this DO is the common for this both triangle. So we can say these two triangles AOD and DOC equal in all respect, and we can say this AO equals to this one, AO equals to OC, and this angle AOD, this angle, this AOD equals to angle DOC. So it is a straight line AOC, so it is a pi, 2 pi. So these all two angles are equal, means these two angles are pi. Now you see here this angle AOB equals to angle DOC. This AOB, angle AOB equals to angle DOC. Why it is equal? Because it is a vertically opposite. These two angles are this vertically opposite, and this DOC is the right angle, so it should be right angle. Now we can say this all four angles are right angle, and this the AO equals to BO equals to OD, and AO equals to OC. Now you can say this point is the bisector of this both diagonal. So we can say this diagonal AC and BD is the bisect one another and right angle at point O. So this is our proof. Thank you.